Hello, good evening guys. Today is 27th of October 2022 and today I want to do a subtopic on photoelectric effects. This is a topic in physics, Form 4. And today I want to do a subtopic and more specifically on the graph work involved in the topic. Now the graph work is related or uses an equation that we have learned in the topic, that is the Einstein's photoelectric equation, which states that the amount of energy of the radiation is the sum total of the work function, the minimum energy required to dislodge electrons from the metal surface, and the kinetic energy that is going to be possessed by the electrons once they are dislodged from the metal surface. So E equals to the work function plus the kinetic energy. Now, how do we get the energy possessed by the radiation of light that is going to be used to dislodge electrons from the metal surface? Through a process called photoelectric emission. So E is obtained using the equation E is equals to HF, where H is the Planck's constant and F is the frequency of the radiation of light used. On the other hand, we have the work function, which is obtained using the same formula, that is HF, but instead of using just HF, we instead use HF naught, where F naught is the threshold frequency. Threshold frequency is the minimum amount of frequency of light required to dislodge electrons from a metal surface. Then we have kinetic energy. Kinetic energy is the energy that is going to be possessed by the electrons. Remember, electrons, from what we have learned about the cathode rays, they possess kinetic energy, meaning once they are dislodged from the metal surface, they start to move, and anything in motion will possess kinetic energy. And for us to calculate the amount of kinetic energy, there are two equations involved. The first one is a half mv squared, a half multiplied by the mass of the electrons multiplied by the velocity, the square of velocity at which they are moving. Alternatively, you can use the equation EV, where E is the charge on an electron, while V is called the stopping potential. So in this subtopic, we shall consider using the equation EV to calculate kinetic energy instead of a half mv squared. So if we substitute these values except for work function, the equation we get is E is equals to, from the equation E is equals to work function plus kinetic energy, we get HF equals the work function plus EV, where EV is the kinetic energy. So the graph that is supposed to be drawn is a graph of stopping potential, and the SI unit of stopping potential is volts, again is frequency. The SI unit of frequency is Hertz. So we have frequency on the x-axis, while we have stopping potential on the y-axis. That means that if we are to look at this equation, we are to make y the subject, stopping potential V the subject of the formula, so that we can try to make this nonlinear equation linear. This is a topic that we have learned in maths, so we are just practicing the same. So how do we go about that? We shall start by first taking work function to the other side, meaning on one side of the equation sign, we are going to be left with EV equals to HF minus the work function. Then because we want to make V the subject, we shall divide both sides by E, the charge on an electron. So that we get V being equal to, E here is acting as the LCM, meaning we can distribute it to each of the terms on the numerator, so that we can be able to get HF over E minus the work function over E. So this equation is now in the form, the general form of an equation of a straight line. That is y is equals to mx plus c, so that we can be able to compare them side by side. So on the y-axis, we have the stopping potential. On the x-axis, we have frequency, meaning what has been left, that is h over e, is supposed to be equal to the gradient. Another thing we note is that the gradient is positive, meaning we have a rough idea of how the diagonal is supposed to be slanted. Going to the other term, that is the y-intercept, we note, number one, the y-intercept is negative, meaning remember, the y-intercept is where the graph cuts the y-axis, and at this point we expect the y-intercept to be a negative value. So we not only have the nature of the diagonal of the line, but also where the line is supposed to be cutting the y-axis, not on the positive side, but on the negative side. So from this graph, how can we use it to determine some of these constants, like the Planck's constant? So we shall start by first calculating the gradient of this line, which is going to be given by change in y over change in x. So gradient m equals to change in y over change in x, which is supposed to be equated to h over e. Note at this point, e is going to be taken as a constant, and the value that is supposed to be used is 1.6 times 10 raised to power negative 19 coulombs. Remember, the SI units of the charge, amount of charge possessed or stored in a given body, is supposed to be given in coulombs, or the SI units of charge is coulombs. So having said that, once we calculate the gradient, we can equate the gradient to h over e, meaning we can make h the subject by multiplying both sides by e, such that h is equals to me, the product of the gradient multiplied by the charge on an electron, which we have already highlighted earlier what is supposed to be. Now for the y-intercept c, we note that c is going to be negative. So negative c, note here that c is standing for the y-intercept, is supposed to be equal to the work function, negative work function. As we can see, this term is negative work function over e, meaning we can still use this equation to determine the value of the work function. And at this point, noting that both sides of the equation sign has a negative sign, we can choose to multiply both the numerator, both sides of the equation sign by -1 or divide by -1, such that we get c is equals to the work function divided by e, such that if we multiplied by e on both sides, it means then that the work function is going to be given by the product of the y-intercept and the charge on an electron, which is 1.6 times 10 raised to power negative 19 coulombs. So having obtained that, so the graph has helped us get two things. The first thing is the Planck's constant. The second thing is the work function. Once you obtain the work function, it means then that there are other quantities that we can use, we can calculate. So first of all, work function, we learned earlier, or so earlier, that is supposed to be given by the product of the Planck's constant and the threshold frequency. So meaning, having obtained the Planck's constant and the work function, it means that it is possible for us to get the threshold frequency in Hertz. Apart from that, earlier on under waves 1, we learned that the velocity of any given radiation or wave can be given by the product of its wavelength and frequency. So if we make the frequency the subject, we get frequency equals to the speed or the velocity of the wavelength divided by the wavelength. So if it is the threshold frequency, then and also considering that the velocity of light is already given, which is abbreviated by a constant capital C, it's then going to be given by the threshold frequency equals to C over lambda naught, or the threshold wavelength. So it means then that the work function equals to h C over lambda naught if we substituted the value of f naught to be C over lambda naught. So from this graph, there are 4 quantities that can be obtained. First, the Planck's constant. And by the way, from our earlier calculations, we already know the estimated value of the Planck's constant, that is 6.63 times 10 raised to power negative 34 joules seconds. So this is the value that we are going to be expecting once you take the product of the gradient here multiplied by the charge on an electron. So then we can also obtain from the graph the work function. We can also be able to calculate the threshold frequency once we have the Planck's constant and the work function, and we can also be able to obtain the threshold wavelength. C, the speed of light, is supposed to be 3 times 10 raised to power 8 meters per second. So with that, guys, I hope you have gotten to learn something, and thank you for listening, and God bless you. See you in our next video. Bye.